Okay, number one says a 25-gram bullet is moving at 660 meters per second when it encounters a block of wood. It passes through the block of wood with a speed of 460 meters per second, and the average force slowing the bullet down as it passes through the wood is 11,400 newtons. So I got A right, and B asked what is the width of the block of wood. So to find the width, you use the kinematic equation v squared equals v naught squared plus 2ax to solve for x. But you don't have a, so to find a, you use F equals ma since you have the force and the mass. And then you get that a and plug it into the equation, and you get x equals 0.246 meters. All right, number two says the 800 kilogram roller coaster car begins the run traveling 35.3 meters per second. It makes the jump and travels around the loop before going uphill. At the end, the coaster rolls up the hill until it comes to a rest. From there, it rolls backwards to the ride. There's no friction. Okay, so I got A right, and then B asks how much energy does it have at the top of the loop? Well, that answer is the same as A because the energy is the same amount. It just is transferred some into potential and some is into kinetic. And then C asks how much energy does it have when it reaches the highest point? And once again, it's the same answer. It's the 498,436 joules because at this point it's just all potential energy. Okay, D asks how fast is the car going at the top of the loop? So what you do is you take the 498,436 joules and you subtract potential energy, or MGH, which is 800 times 9.8 times 33, and you end up with 239,716 joules. And then you set that equal to 1 half mv squared and solve for v, and you get 24.5 meters per second. E asks how fast is the car going when it reaches the bottom of the loop? So you do the same thing as the last question, but you use 5 as the height instead of 33. So you do 498,436 minus 800 times 9.8 times 5, and you end up with 459,236. And then you set that equal to 1 half mv squared and solve for v, and you get v equals 33.9 meters per second. Number four says a 2.5 kilogram puck moves along a frictionless channel at a speed of 2.5 meters per second. A second 1.8 kilogram puck moves in the opposite direction with a speed of 3 meters per second. The first puck rebounds with a speed of 1.2 meters per second, and then it asks what is the final velocity of the second puck. So to solve for this, you just do m1v1 equals m2v2, but you keep the signs right. So you do 2.5 times 2.5 minus 3 times 1.8 equals negative 1.2 times 2.5 plus 1.8 times v. You solve for v, and you get v equals 2.14 meters per second. B asks, what is the impulse on the 2.5 kilogram puck? To find that, you just do the impulse equation, which is mass times change in velocity, which in this case is 2.5 times 1.2 minus 2.5, and you get negative 3.25 kilogram meters per second. C asks how much energy is lost during the collision, and to do that, you sum up the energy before the collision and after, and you subtract it, and you get the difference is 9.99 joules is lost. Number five says a 0.95 kilogram ball is dropped from a height of 1.35 meters. It hits the floor and rebounds up to a height of 0.98 meters. So I got A right, and then B asks what is the momentum of the ball just as it leaves the floor. So to solve this, you set the kinetic energy equal to the potential energy, cross out the mass, and then you solve for V. And then once you get that, you can plug in the equation P equals mv, and you get P equals 4.161 kilogram meters per second. C asks, what is the impulse exerted on the ball by the floor? And to do that, you just do the change in impulse, which is 4.161 minus 4.887, and you get negative 7.726 kilogram meters per second. Letter D asks, if the ball is in contact with the floor for 0.0055 seconds, what is the impact force on the ball? So to find that, since force times change in time equals change in P, you have to divide P by the time, so you get force equals 0.726 over 0.0055, and you get 132 newtons. So number 6 says a 3 kilogram block is pushed with a force of 14 newtons, causing 270 joules of work to be done at a distance of 26 meters. So, A asks, at what angle was the force applied? So to solve this, I drew a triangle showing which direction each force is being applied, and then you set the work equal to the force times distance. But since you're trying to find the bottom leg, which is the cosine of theta, you set 270 equal to 14 cosine theta times 26, which is the distance. And you get theta equals 42 degrees. So E asks, if the block started at 1 meters per second, how fast was it going at the end of the 26 meters? So to solve this, you just use the kinematic equation, b squared equals b naught squared plus 2ax, and you don't have a, so you have to use F equals ma since you have the force and the mass. So you end up getting 3.46 for A, then you plug that in and you get the velocity equals 13.5 meters per second. So letter F asks, after accelerating for 26 meters, the force stops and the block strikes a spring with a spring constant of 1,000 newtons per meter. How far will the spring compress before the block comes to a rest? So to solve this, you do the kinetic energy equals the spring energy, which is 1/2 mv squared equals 1/2 kx squared. You cross out the 1/2. You get x squared is equal to mv squared over k. And then you solve for x, and you get x equals to 0.74 meters.